My name is Ron Dominguez, and this is my EEE 120 Lab 0 recording. So here I have my file in digital, so I'm going to run it. So we have our inputs A and B, these squares. We have our wires. Some are light green, some are dark green. We have our NOT gates with the circle and triangle together. We also have our AND gates. Then we have wires leading to our OR gates, and we have our output Y. Um, the red dots represent outputs, and the blue dots represent inputs. So to test this, this is an exclusive or XOR gate. So basically, output Y should be true when the inputs are different, and then it should be false or zero when the outputs are the same or the inputs are the same. So as we can see, both A and B are zero or false, and then so meaning they're the same, and our output Y is also zero or false. And I click on A because you can see that renders our output to be true or one. If I take A off and put B on, put B as true, that renders our output Y to be true. And then if I put both A and B to be true, that renders our output to be false. Exclusive OR basically means that like only only one in a two input gate, for example, only one can be true, meaning either A or B, not both or not neither. We can also test our circuit using this text file and converting our inputs and outputs to a hexadecimal form with two groups of 4 bits. So as you can see, we have eight. The circuit is 8 bits. Bit 0 is the B input. Bit 1 is the A input. 2 and 3 are unused. 4 is the expected output Y, and then 5, 6, and 7 are unused. 7 being on the left and 0 being on the right. So, for example, if A was to be true, that would be 1. Um, and if B was false, that would be 0. So then our first hexadecimal group would be 0010, which would mean that that would equal a value of 2 on the right hand side, and then Y would be 1. So that's 0001 and 1. And that would be 1 on the left hand side. So as you can see that this matches this output case with 2 on the right and 1 on the left. And we can also test it where B is 1, so the rightmost value is 1, A is 0, and then all our unused values would be 0, and then Y, since it's exclusive OR, would also be 1. So on the left, we'd have 0001, rendering a hex value of 1, or binary value of 1, or both hex value and binary value. And then on the right, we'd have 0001. So both the right and the left-hand side would be 1. And as you can see, that is also one of our test case, where the left obviously being the output. Those are both the test cases that render the output true. And then we can also test it where A and B are both false or 0. So then on the right, we have 0000. And on the left, since our output would also be false, we'd have 0000. And that would be in hexadecimal, that would be 2 zeros on the left and the right. So that's this test case at the top. And then our final test case, it would be with both A and B true. So on the right-hand side, we have 0, 0, 1, 1. And then if both of them are true with the exclusive OR gate, Y would have to be false. So on the left, we'd have 0, 0, 0, 0, equating to 0 in hexadecimal. And then on the right, we'd have 0, 0, 1, 1. 2 plus 1 is 3, so we have 3 on the right. And then that's also our final test case. And then here is this circuit on GDK wave. And then we just would compare this to the waves on the manual. Obviously, the one at the top is input A, which looks like this. Then we have in the middle input B, which the wave looks like this. And then Y, which is our output, looks like this. Thank you for listening.